Hello everyone, you are welcome back. We have another simple question to solve today, and the question we are solving today is on theory of logarithm. But here we have two equations. This is the first equation and this is the second equation. That means we are going to solve the two simultaneously. We are given log x 27 plus log y4 is equal to 5. That is the first equation. And the second equation we have log x 27 minus log y log base y power 4 is equal to 1. Look at this simple question that we are given. Let's call this one equation 1 and this one equation 2. Of course, we know that when we are solving simultaneous equation, we have different methods of solving simultaneous equation. We have substitution method. Yes, we have elimination method. We can solve simultaneous equation graphically, and we can use matrix method to solve it too. But in this particular case, the best method we can use to solve this is elimination method. And you know, elimination method deals with the coefficients, the number before the log, the number before the log, the number before the log, the number before the log. And once the coefficient balances as if they are the same, then we don't need to stress ourselves. In this case, the coefficient of x of this first one, log x, log base x power 27 here is 1. This one too is 1. I can actually subtract this so that I will eliminate x. So if I subtract this equation now, that means I will have this equation minus this equation. That means x is eliminated. It will give us 0. 1 minus 1 will give us 0. But if you look at this, we are going to have, there is a 1 here, 1. So it is silent. 1 minus minus 1. That means we are talking about 1. Plus minus minus will give us plus. So here we are going to have 2 log y4 is equal to 5 minus 1. That is 42. We have this. That means we have this and we subtract this. From here, I can divide both sides by 2. So these two will cancel. 2 here is 1, 2 here is 2. That means I am left with log y4 is equal to 2. I have this. The next thing I should consider doing now is to remove this log sign. And when I remove this log, this base y will be raised to this power 2. That means I am going to have here now y raised to power 2 is equal to 4. So from there I will have y2 is equal to 4, 2 is 2 raised to power 2. These two will cancel. So therefore my y is equal to 2. So I have gotten the value of y. I now need to get the value of x. For me to get x now, I am going to substitute the value of this y into any of these equations, either equation 1 or equation 2. Let's consider equation 1. That means I will have log x 27 plus log the y now is 2 raised to power 4 is equal to 5. Looking at these, I can simplify this. I have log 2 4. I can call this one is equal to p. The next thing I can do here is to simplify this. I will have 2 raised to power p is equal to 4. That means I can now have 2 raised to power p will be equal to 2 raised to power 2. The base are the same, the 2 will cancel. So my p now will now be equal to 2. That means the whole of this now will give us 2. Going back to this equation now, we have log x 27 plus 2 is equal to 5. I can move the 2 to the other side. If I move the 2 to the other side now, I am going to have here now I will have log x 27 will now be equal to 5 minus 2. That will give us log x 27 is equal to 3. I have this. It is now like this one that we solve here. So I now need to remove the log side. That means that we have x raised to power 3 is equal to the power 27. So my x raised to power 3 now will now be equal to 3 raised to power 3, because 27 is 3 times 3 times 3. So the powers we cancel, so our x now will now be equal to 3. So therefore, x is equal to 3 and y is equal to, we have gotten the power of y, 2. If we substitute the values of both x and y into this part, into this first equation here, you will get 5 as your answer. We are going to stop here for now and we take it up from here next time. Thank you for watching. God bless you.